Hi, so to start the Daylight Lab, we were given this set of data and we were told to make a graph and find an equation for it. So when you take a quick look at this, we can see the highest is June 21st at 15.27 hours of daylight, and the lowest amount of daylight in the year is on December 21st to 9.07. So this means the midline is going to be 12.17 because that's the point in between the two, and then the amplitude would be 3.1. So if we quickly sketch this graph, which I've obviously done in the past 5 seconds, the hours of daylight is the y-axis and the days of the year is the x-axis. We'll start at December 21st, which is at 9.07, and the number of daylight hours in a day will increase all the way to 15.27 before dropping down to December 21st of next year. What was interesting was that December 31st really doesn't play a role in this graph, and that was what confused our group when we were making it. So the equation for a sinusoidal function is f of t equals a sine b t minus h plus k, and we already know that the amplitude is 3.1 because that's the distance from the midline here and here. And the period was actually surprisingly easy to find. Since it's 2 pi over b, it's just 2 pi over 365. The h is where there were a lot of problems because I had to figure out whether it was plus 10 extra days or minus 10 extra days. But we know that it's 365 days in a year divided by 4, which is 91.25. And you have to subtract the 10 extra days because that's getting us from December 31st to December 21st. The k is pretty easy to find, as that's just the midline, and it's the average hours of daylight in a day, and that's 12.17. So if we put this all together, we get this equation. So to find the 2 days of the year where it's the average hours of daylight, we just plugged in this graph and the midline, and we found the intersection points, which was pretty simple. But you can also solve this algebraically, which is a little cooler. If we just plug in 12.17 to the y, because that is the midline, that cancels out on both sides, and then we can divide by 0 by 3.1, which also cancels out the 3.1, and then we can take the inverse sine of 0, which also cancels that out. So it ends up nicely being 0 equals 2 pi divided by 365 t minus 81.25. Now 81.25 ends up being March 22nd, just because that's the 81st day of the year when we're starting from December 21st. And that's just also because it's 91.25 minus 10. So to find the other point, we just add pi, or 100, or I guess half of the year. So it's 81.25, which is our first date, plus 91.25, plus 91.25, which is 263.75. And I just thought that was pretty cool because that was also a pretty simple way of doing things. So that is how we got the sinusoidal equation for the Daylight Lab, and I will talk a little bit more about it in my written reflection. So thanks.